Okay, hi guys and girls. Today we're going to try to do multiple conversions. So let's take a look at our notes package. In our first example, we have how many oxygen atoms are in 3.30 times 10 to the negative 3 grams of carbon dioxide. This means we're going to have to be doing multiple conversions. So make sure that you get out your handy dandy supermole map. We're going to need to be going from mass to atoms. That means in between we're going to have to stop at moles. So we're going to go mass to moles, and then from moles we're going to go to atoms. Okay, so let's try this out. First of all, we have started with 3.30 times 10 to the negative 3 grams. And we want to get rid of grams, so we need to use a conversion. To get rid of grams, we're going to be needing to use the top conversion. We have two different conversion factors. We're going to need to use the top one. That means 1 mole over the molar mass in grams of carbon dioxide. So times 1 mole over the molar mass in grams of carbon dioxide. What's the molar mass of carbon dioxide? Well, there's 1 carbon, so that's 12.0 grams from our periodic table, and there are 2 oxygens, so that's 2 times 16.0 grams. Add all of that up, and we end up with 44.0 grams in 1 mole of carbon dioxide. So let's take that into our conversion. 44.0 grams. That means that we will cross those out, multiply the tops. It's a whole number, so we can put that over 1, and we end up with 7.5 times 10 to the negative 5 moles. We're not done yet because we want to go to atoms. We don't want moles, so we need to convert from moles to atoms. So 7.5 times 10 to the negative 5 moles. Now, since we're talking about carbon dioxide, this was moles of carbon dioxide because this was the molar mass of carbon dioxide. And we had started off with grams of carbon dioxide. Okay. We are going to be converting to the number of molecules of carbon dioxide first. Okay. So in 1 mole, we will have a certain number of molecules of carbon dioxide. And that number is Avogadro's number. Our 6.02 times 10 to the 23 atoms, particles, grammas, muffins, whatever it happens to be that it's a mole of. So right now it's a mole of carbon dioxide. So this is going to be 6.02 times 10 to the 23 particles, molecules of carbon dioxide. We're going to be using our top conversion because we want to get rid of moles. Our bottom conversion would help us to get rid of atoms. So 6.02 times 10 to the 23. Once we've done this math, we will be finding out that we have a very large number. If you end up with a very small number, perhaps you divide it and try again. So I've ended up with 4.515 times 10 to the 19 molecules of carbon dioxide. Are we finished? I don't think so. It looks like we wanted the number of oxygen atoms. So in every molecule of carbon dioxide, taking a look back, we have 1 carbon and 2 oxygens. We're going to be writing ourselves a conversion factor. We need to convert between carbon dioxide and oxygen atoms. So we want to get rid of molecules of carbon dioxide, molecules of CO2, carbon dioxide, 1 on the top, 1 on the bottom, and number of oxygen atoms in one molecule is going to be 2 atoms. And this is what I've ended up with. Finally, let's take a look back at the number of significant figures in our starting number. That's 1, 2, 3. So we should end up with 1, 2, 3 for our final. And this is 9.03 times 10 to the 19 atoms of oxygen. All right, that's all for today.